Myself, M. Karthik Kumar Reddy, working as an assistant professor in Nalla Narasimha Reddy Education Society's group of institutions in the Department of Civil Engineering in Foundation Engineering subject. I am going to explain about Unit 4 Shallow Foundations. First of now here we are going to discuss about ultimate bearing capacity of shallow foundations. Now the important criteria which we have seen that the foundation must not fail in shear, and that criteria is for this foundation. Coming to the important considerations, now it has been found that the factor of safety in this case of shallow foundation does not fail in shear. Now mostly the failure takes place, or when we say failure, we mean it means the failure due to excessive settlement and especially the differential settlement. We will have to keep this differential settlement within permissible limit, more dangerous to the stability of structure. Now in order to find out the bearing capacity of in order to find out the ultimate bearing capacity of shallow foundations from shear failure criteria, there are many theories which we are given by various researchers. For that, let us take soil. So this is the foundation which we can see in the figure, which is resting on the soil, foundation which is resting on the soil, and here the load is acting on the foundation, and above the foundation we are going to apply the load of intensity Q, and the width of the foundation is capital B. Now when we apply the load, when we keep on increasing the load, there will be a settlement at a particular area, that is foundation settlement due to the load we are going to apply. Due to the load intensity whatever we are going to apply, foundation is going to settle. This is the load intensity settlement relationship. Now when you increase the load per unit area, that is the pressure which the response load intensity settlement response will be like this. In this, on the axis, load per unit area is represented on, means load per unit area is plotted on x axis, and settlement of the foundation is plotted on y axis. Now you will find that with the increase in load, there is an increase in settlement, and a condition reaches behind where there is no increase in the load, but there is sudden drop of the general shear type of failure. Now in another case where you will find that on increasing and there is no clear cut failure on the second one, and the settlement and corresponding strains are very excessive strains. Now we classify these two as the general shear failure. Now based upon this we classify this as general shear failure and local shear failure. Now so the failures, one is general shear failure, another one is local shear failure. And in the bearing capacity failures, one more failure will also be taking place, like punching shear failure. Now in the case of general shear failure, in this situation, the figure we can observe there is a general shear failure. Soil mass, and on the soil mass is resting of foundation of width B. Soil mass is resting on the foundation of width B, and this is the load intensity, that is the ultimate load or the bearing capacity of the soil, that is QU. Ultimate bearing capacity of the soil is QU. Original ground surface is shown here. On the figure we can observe the original surface of the soil. Now with the increase in the load, there is a settlement of the structure, and you will find there are three clear cut zones which are found below the foundation. There are three clear cut zones which are found below the foundation. This zone we call it as the elastic zone, that is elastic zone. Zone 1 is called as the elastic zone, and zone 2 and zone 3 are called as the plastic zones. All of you should remember this. Zone 1 is called as the elastic zone, and zone 2 and 3 are called as the plastic zones. Now there is a development of the clear cut of plastic zones. Development of clear cut of plastic zone is observed, and you will find that there is a wheel type of bulging means bulging type of failure is taking place as a surface on the ground surface. This is in the case of general shear failure. There in the general shear failure we can observe that there is a elastic zone and plastic zone. First one is the elastic zone and second one and third one is called as the plastic zone. So in the case of general shear failure, a triangular wedge shaped zone of soil marked, it presses the zones marked 2 and 3 sideways and then upwards, means it presses sideways and upwards at the ultimate pressure, ultimate bearing capacity of the soil that will be passes into a state of plastic equilibrium, means it will be changing from elastic condition to elastic equilibrium condition to plastic equilibrium condition, and the failure is taken by sliding. Now such type of failure in the case of dense sand with relative density greater than 70, and in the case of another type of failure also will be taking place, which is the local shear failure. You will find that the zones or plastic zones are not clear-cutly defined, but they are subdued, and you will find that the bulging is varies as small as compared to the general shear failure, means bulging will be as small as compared to the general shear failure. In the third type of failure, which is punching shear failure, you will find that there is no development of bulging and the zones are not clearly defined. In the punching shear failure, there is no development of bulging and the zones are not clearly defined. Now in the case of local shear failure, the triangular wedge shaped zone of soil marked 1 below the footing moves downwards, but unlike it ends somewhere inside the soil. However, some signs of bulging are seen, but these are not pronounced in the case of general shear failure. Such type of failure occurs in the loose to medium sand with relative density of 35 to 70%. And the third type of failure, which we call it as the punching shear failure. In the punching shear failure, the foundation penetrates. In the case of punching shear failure, the foundation penetrates into the soil without any bulging on the surface. The failure surface never reaches the top surface or the sand surface. Here in the punching shear failure, the failure surface never reaches the top surface or the sand surface. Now this occurs in the case where relative density is less than 35%. On the basis of the model study, this is a relationship between relative density of sand and the relative depth of the foundation in terms of df by b ratio, that is depth by width ratio. Now you will find that for this case there are different zones in which you will find general shear failure, local shear failure and punching shear failure. For example, let us say your depth is 2 and width ratio is equal to 1, and corresponding to that is the point below, there will be a local shear failure, and other will be general shear failure, that will be depending on the relative density of the sand. However, it is stiff or how dense, depending upon the stiffness of the soil and depending upon the type of stratum, we are going to decide which type of failure is occurred. Now in nutshell, we can say that in the case of a stiff clay and dense sand, normally we get general shear failure, and in the case of loose sand and dense clay and or dense sand and loose soft clay, we get the local shear failure. So on the basis of this, between we can get the intermediate. Now these values are also defined when we say dense sand, if angle of failure, if angle of shearing resistance of sand is less than 28 degrees, if angle of shearing resistance of soil is less than 28 degrees, then between it is a intermediate failure. When the angle of shearing resistance of sand is less than 28 degrees, then it is a intermediate failure. With this we have completed what are the different modes of failures in footings, like general shear failure, local shear failure and punching shear failure.